Stanislav Velkov. I'll be your substitute lecturer today. If at any point I start talking Bulgarian, just interrupt me, tell me to switch back to English. I might be a bit rusty, so bear with me. Today we're going to talk about console input-output. So we're going to be dealing with the read line, the write line. We're going to see how you can convert strings to integers or any other type basically through built-in functions. You'll check out some other interesting functions like read that you probably haven't seen before. You can only use read line, I guess. Read is something that has a very different idea behind it. It basically converts characters to integers, which are interchangeable in the case of C# because characters are just ASCII symbols. They're all represented with an integer. We'll also see how you can read numeral types. That's basically a conversion. So it should be all pretty simple, I hope. If at any point you have any questions, just raise your hand. I'll try and check the room for any questions and address them. Any questions before we start? Yep.
Shall we ask our questions in English?
Well, you can ask them in Bulgarian. I'll just translate them for the video. Yeah, it's fine. You don't need to speak English. Just ask your question in Bulgarian. It's fine. All right. So you should have been introduced to the console at the first lecture that had to deal with introduction to programming, and you must have been using it so far to deal with all the output that you have to provide for your programs. Basically, there are many different ways to output something in C# in any programming language. But in this case, we've always used the console. So because this is an introductory course, we'll still be using the console. So yeah, I hope most of the things you've already seen, so it won't be anything entirely new. You'll probably see some new topics on how to convert between different encodings, for example, from, let's say, Windows 1.251 to UTF-8 or UTF-16, etc. But most of the things, as I said, won't be new to you. The console can be used to show human-readable form of something that is machine code. So basically, we only use that for our own comfort and for other programmers like us. We don't use it for the computer because the computer understands machine code, it understands bytecode, it understands binary, and it doesn't really need to use the words that we use in our everyday life. So basically, the console is just for our own convenience. And obviously, if you want to use a console, it's a built-in class in the library system. So you don't have to import any third-party libraries. It's something that everyone uses in their code. So it's out of the box. It's basically in the C# package. If you like to read input, so you have some stream or some flow coming to your program, to your code, through the console, you can use the following methods to actually parse the information, to actually read what's on the console. To also read, which we'll see later on, it just reads a single character. And it actually has very, very interesting behavior. It just reads it as an integer. So it's kind of tricky, you should see that. The read key reads a combination of keys. For example, if I press the control key, which is actually an input key, it's not like ABC, it's not part of the alphabet, it's not a character that if I press control or escape or some other key on the keyboard, I can track that with the read key command. Also read line, it's probably the only one that you've been using so far. It's used at any point where you need to read lines of code from a file, for example, or if you want to check if you're on the exam and you have the input coming from the console, you read it through read line most likely because it's faster to parse lines and parse different characters if you know already in advance what you'll be receiving as input. If you'd like to print some output, then there are obviously the two ways that you can do that. Write, which doesn't end with a new line, and write line, which basically is the same method as write, but it puts a new line symbol at the end of the string that you input. So basically those two are completely equivalent, with the only difference that you get a new line at the end of write line and you won't get a new line at the end of write. You can get the behavior of write line by just calling write and adding a new line at the end. But be careful because there are different ways to put a new line in different operating systems. In Linux, that's only the /n, that's the symbol for a new line. In Mac OS, I think it's /r, and in Windows it's /r/n, if I remember correctly. It will be definitely shown in one of the slides where you can check it. Alright, so if you'd like to print a single integer, it's pretty straightforward. You must have done it 1,000 times by now if you've done all the homeworks and you've probably done some exercises regarding any manipulation with data so far. But yeah, you just introduce a variable a, which is in this case set to be 15, and then you use console write, so you won't have a new line at the end. So when you print the variable a, it just prints the value 15. If you'd like to print more than one variable, then you can use the formatting string. That's something that's very important. You probably use it a lot as well, because it's easier to structure your output if you use the formatting syntax. So those edge, well, it's not really an edge, but yeah, the curly braces. Those curly braces, I must have zoomed in somewhere. Yeah. What was it? The tab, yeah. Alright. So, for example, this is an argument. It says curly braces 0. So, the escape key is not the way to end this. Alright. So yeah, if you, for example, have this argument, which is curly braces 0, it basically associates that with the first argument that you put after your string. You must have been using write and write line, those two methods by now, by simply inputting a string, which is this string here, right? But now you can extend this. You can add something at the end, and instead of using string concatenation, just simply using this plus symbol to join the strings that you want to output, you can actually put those as arguments and put placeholders like these two, 0 and 1, and actually the 2. So these three are called placeholders. You have the 0, you have the 1, and you have the 2. And those three are called placeholders. And they represent the arguments in order. So A, in this case, is represented by curly braces 0. So whenever you put curly braces 0 in your string, it will be replaced with A. In this case, it will be replaced by 15.5 because it's a double value. It's a double value. Whenever you put 1 in your code, it will be replaced by B, which is 14 in this case. And wherever you put 2 in your code, well, it's getting a bit messy now. So whenever you put 2, it's associated with the second argument, and we start reading 0, 1, and this is our second argument. So this will be replaced in the string here. So we basically have 15.5, which is A, plus 14, which is B, is equal to A plus B, which is 50.5 plus 14. So you've got the answer you're probably expecting. Any questions about this behavior? we'll definitely be seeing some more. Yeah.
So the placeholders should always begin with 0?
Yeah, they always begin with 0, they're 0-based. There are some tricky parts about it because you can sometimes have a different number of placeholders and a different number of arguments, and we'll probably see behavior like that later on. And in one case you'll get an exception when there is no such placeholder. For example, you have 2 arguments and you want to get the third one, then you'll get an exception because there is nothing that you can replace the placeholder with. But the other case, which we'll also see, when you have too few placeholders and too many arguments, that's completely fine because you're just not using all your arguments. You're just using this, for example, the first 2 that you put. If, for example, in this case, I write here mama and I say C, D, and then end this. This is perfectly fine. I'm using only A, B, and A plus B. I never use curly braces 3, which will be C, or I never use curly braces 4, which is D. So this is perfectly fine. I'm just not using them. So the compiler won't say anything. At runtime, you'll probably see no exception as well. The other case, though, if you have too few arguments, for example, if I only had A and B, and A plus B was missing, then the compiler, I guess, I'm not sure that we'll see that if it's a compile time or a runtime exception, but you'll definitely get a problem with nothing to exchange the 2 with. You have the 0 to be exchanged with A, the 1 to be exchanged with B, but the 2 will just blow up probably. We'll see. All right. Any more questions about this? We'll definitely see some demos, I guess, to become more clear. Yeah, so printing a string variable plus new line. That's what I was explaining at the start about the difference between console write and console write line. When you use console write line, you basically use console write and then add /r/n, which are what were they called? They were terminating symbols. I can't remember, but yeah, those are interpreted by the console as symbols for a new line. So basically, you won't get /r/n as output. You won't see them. You just have the cursor move to the next row, the next line. And yeah, in this case, you just print the string hello C#, and then you get a new line. So basically, when you start writing again, you'll be on a different row. If you would like to print more than one variable, that's kind of the same as the previous slide, where we said that you have a placeholder 0 and a placeholder 1. You just replace. Well, I didn't have the zoom it available. Yeah. So everywhere where you have the 0, it will be replaced with a name, and everywhere you have a 1, it will be replaced by year. So in this string, you just get the name, which is Mary, was born in, and then the integer, which was 1987. So it's behavior we expect. This should be probably the demo, or no, it's still in the demo, okay? But it's a simple example. You have 2 strings and an integer. The strings are name and town. You have Peter, and the town is Sophia, and you have the integer age, which is 18. So I guess Peter is 18 years old. So we write, you use console write, so we won't get a new line, and we say, and we use the placeholder 0, 1, and 2 because we have 3 arguments. 0 will be replaced by name, 1 will be replaced by age, 2 will be replaced by town, and we get Peter is 18 years old from Sophia. If we continue writing, then we'll write on the same line. There was no symbol for a new line at the end of the previous statement, so continue writing on the same line. And then if we say console write line, then this will still be on the same line, this string. Next sentence will be on the new line, because the previous one still didn't end with a new line. But now the next line, console write line bye-bye, this string bye-bye, will be on the new line, because the previous one had a new line at the end. Is everything, yes. Is everything clear? Okay, so formatting strings. as I said, the index is a zero-based index. So we start, the first argument is the zero argument, and then we have the first argument, which is basically the second in a row. So yeah, we have a zero-based indexing. You have to make sure to cope with that, because sometimes it's not. If you write a lot of programs, if you write a lot of software, you'll get used to the zero-based index. But when you're a beginner and you just start with it, it's not completely intuitive. It's not completely intuitive to start cutting at zero. Well, some people say it should be, but it's definitely not at the moment. There is some discussion about what's a natural number as well. If zero is a natural number, if nothingness is something that's natural. But yeah, in programming, most of the things that you'll see will be zero-based. So you have to get used to starting everything with 0, 1, 2, etc. That's a different problem there as well with the length, because the length will be what you expect, but then the last argument will be n minus 1. So yeah, it's okay. Get used as well. The alignment, you can use the alignment to basically say how many spaces or how many blank places you want to leave between the argument and the next one, or between the previous argument and this one. And this is done through the optional comma and then alignment, or use the ellipse thingy. Yeah. So this is the optional argument alignment, which you can use to basically align the next input that you use, the argument you have. So as you see, this is all the curly braces. So this is what we've been seeing so far. This is the 0, 1, 2, etc., which is the index. This is the first part, the index. And then we haven't used those, but those are still available to us. Those two are optional. When you see square braces, it usually means something is optional. It's not always true. In this case, true. It will be true in many cases. Might not be true with attributes, because attributes are not optional. They might be, but their syntax is the same. And then the third part, which is, okay, so the alignment, you'll see a demo about it, but yeah, if it's positive, then you see right alignment. So be aligned to the right. And if you put a negative integer, then it will be aligned to the left. You'll see that. Might not be completely clear at the moment, but bear with me. And the last argument, which is the format string, this is something that you put at the end with a colon in front, and you say, for example, format this as a number, or format this as a, say, float, like integer or float, or a natural number, or a decimal. There's so many different formats. You need to like check them, and you don't have to remember them, because you won't be using them all the time. But there are a lot of them. There is a whole list on the MSDN site, and we'll see that probably later on as well. So to sum it up, you have the index. For example, I could say, let's see if I can write it. I could say index 3 and alignment -5, and then I could say, for example, I don't even remember them, probably D or something, or there were some different formatters. You'll see them in this lecture definitely. And there, this is okay. We'll see some good examples here. You have the X, which I can't really remember what was it. C, money currency, if I remember correctly. This 0.00 is something interesting. You can actually put the precision with which you print a decimal or a double or a float. Come on, or a float number. So yeah, if you put 0.00, you get 2 decimal places precision. And in this case, where you put, was that 6 zeros, you get 6 decimal places precision of pi, which in this case is not the actual constant pi, it's some double that's named pi, which is a very bad practice, because it's a misleading variable name. You should never do that. It's better to actually name your variable with some cryptic thing, A, B, or C, which no one will understand. But if you name it pi, and it does something completely different than pi, it's absolutely the worst case. It's misleading. If someone cannot understand what A, B, or C is, that's fine, they'll just try and understand. But if they expect it to be something else, that's horrible. So never do that. Never name your variable pi and then give it a 1.234 or any other value different than the actual value of pi. But yeah, in this case, you have some double value and you want to see 6 decimal places. And check this out, it only has 3 in the original assignment. But then it has 6 when we print it because of this formatting string that says printed as 6 decimal places precision. And as you see, there is no alignment here. So these, as I said, are optional. So you don't really have to use them. As we've seen before, you can only use the placeholder. But in this case, you only use the index, which is this. Okay, you only use the index, which is 0. So because it's the first argument, it's the only argument actually. And then you use the format string. So you completely skip the alignment because you don't really need it in this case. You only have one thing that you print on the console. You don't really need to align it. If you want to, you could, and then you have to put like comma, let's say 5 or something, and then it will be aligned to the right with 5 characters. You'll see that definitely later on. Any questions so far? I'm sure we'll be covering it in the demo as well, but yeah, if you have any questions. All right, this is probably the demo. Yeah, let's see. Right, can everyone see this? Yep. Do you want to make it a little bit bigger, or is it fine? All right. Well, this is the first example where we had Peter, 18, and Sophia. I'll be writing something that you might find useful in some cases, but not always. I'll be writing console read line, which is a stopping operation. What does that mean? It means that if I write here, console.readline, the execution of the program will stop at this line 17 and it will wait for an input. If there is no input, if there is nothing to read, it will just stop and it will wait forever. So readline in this case is used to stop the execution. So let's see, if I don't have it, what was the commenting shortcut? Was it Control-Shift-K? No, Control. Okay, I'll just comment it question way. Yeah. So let's see. If we just start the program this way, it will start to compile, it will boot, and then we'll get the whole program executed, right? That's the end. Press any key to continue. That's the end of the program. But if I write console read line here, it will never execute the later lines until I press anything. So you just see it stop now. It's waiting for an input. If I write anything, if I write A, enter, it should continue. If I just press enter as well, enter is a symbol. Enter is the new line symbol. So it's not nothing really, it's something that the computer understands as a symbol. But yeah, it reads a whole line. So this means it will wait for a whole string, so I can write as much as I want. And then it wants an enter, it wants a new line. It cannot continue until it's read the whole line. So if I write endlessly here some rubbish, it will never stop me. But if I say enter, it will read the whole line, it will continue the execution. And I can have the other behavior. I might use console read here. Let's see if it works, I'm not really sure. But yeah, if I write A, okay, it still needs an enter. Yeah, okay, well, there's not much difference. But as I said, console read line in this case as a stopping procedure, as something that just doesn't return the execution of the code to the next line, but instead just stops and waits for an input. let's see it. So, as we said, what was the, okay. As we saw this, we have Peter is 18 years old from Sofia. This was the console write. Let's see if we can get those to on the same. Okay, this is until bye-bye, and then a console write line. Might not be particularly visible, but yeah. We have Peter's 18 Sofia. We have the string, which has the placeholders for name, age, and town, and we have the output. And as you see, the write, all the console writes are on the same line until you have console write line. Next sentence will be on a new line. Next sentence will be on a new line itself is on the same line because there is no new line before it. But after it, there will be a new line. So you will get to bye bye Peter from Sofia on a new line. And as well, as you see, I'm not sure if you can see that, but there is, well, yeah, the cursor is not visible anymore, but if you can see this, after the bye bye Peter line, there is a symbol for new line, and there is a new console write line that's empty here. Let's see, Control 2, okay, yeah. So, this line here, the console write line, it basically adds slash and slash r, or the other way around. You should see that in the slides, but as I said, in different operating systems. In Linux it's only slash n, in Mac it's only slash r. In this case it's both slash r and slash n. I'm not sure in which what the position of those two is. Anyway, and then we have the console write line, which is a completely blank line. This line here is completely blank. There is nothing. Just write line, nothing. And then the cursor, which is visible again, surprise, it's here. So there is a symbol for new line after this. There is a new line which is completely blank here. And then the cursor is on the next one. Okay? And then when we continue the execution, we'll see the rest. Okay, I'll be using this again somewhere. Let's see, there's a double with precision. Then we have the sum, multiplication. Alright, I'll just put it before the, here, let's see. Okay, what do we have? We have, well, not that much. Let's see. We'll have some more, let's see here. Okay, we have the double, which is some variable, which is a better naming than the high one. And then we have the summation and then the product of A and B. And these two can be seen here. You can see the, let's see the zoom. Okay, you see some variables 1.234, but then we add 6 digits of precision. So we get 3 more zeros, since there is nothing after the 1.234. If I add like 5 here, and well, let's see, and this, execute it again, then we'll get 1.2345 and then 2 zeros. So the zeros are actually depending on the amount of space until 6 digits must be filled after the decimal point. If, on the other hand, there was a number which had more than 6, it will be cut to 6 digits after the decimal point. So 1, 2, 3, 4, 5, 6, 7, 8, 9 will be cut to, let's see, 2, 3, 4, 6, 7, 8. And then you'll see the effect of rounding. The effect of rounding is the following. 1, 2, 3, 4, 5, 6, 8. Since the 8 is bigger than 0.5, well, it's bigger than 5, and you have a rounding up. If there was a digit which was less than 5, say 4, 3, there would have been a rounding down. So this is a rounding that you can use for your calculations with decimal or double or float variables, and it's very, very useful actually for printing out something human readable, because you can get an answer which is horrendous and has like 16 digits after the decimal point, but you only want to show 2 decimal points or let's say 3, and then this precision is completely fine with you, so you can just write it with 3 zeros, say. Let's see the rounding down, so that it's complete. So if I have 3 here, then the rounding will be to 7. 1, 3, 4, 5, 6, 7. Yeah. At 5, I think it's depending on what setting is that. Let's see if it's 5, and there's no 9. No. Let's see if it's 5, if it rounds up or down. It decides to round up. So yeah, if you have 0, 1, 2, 3, or 4, it rounds down. If you have 5, 6, 7, 8, or 9, round up. And yeah, the other two should be completely straightforward. 2 times 3 and 2 plus 3 are just these two lines where we have the sum and the product of these two variables. And as you see, those placeholders, they correspond to the consecutive argument in the argument list. So this here is the argument list separated by a comma. So you have the string, comma, and then you list all the arguments. And you can have arbitrary many arguments here. There is no limitation to what you can, to how many you can write. As you see, you might not have seen this. Let's see if I can get it to show. Oh, come on, when I hit Control, it disappears. But yeah, if you can see this here, it might not be visible at the end. Well, I can't really show it because it disappears if I zoom in. But yeah, it says this is the signature of the method. The signature of a method is the output, which in this case is void. Output's nothing. This is not something you have to remember. It's an advanced topic. But yeah, its name, which in this case is console write line, and the parameters, the arguments that are in parentheses, those are the parameters. And in this case, the second parameter is an array. What that means is you can input as many of those as you want because of the keyword params. This is definitely an advanced topic. You'll probably see it later on. What I'm saying is you can input as many as you want in here. It does not matter. You can do it until your heart's desire. Let's see where we got to. Do I have a console running? No. Okay, let's remove the console read line. And then let's see the, all right, F2, that's interesting. That must be some form of float, which has 2 decimal points. It's concise and it represents just that. It represents a float because of the F, and then 2 decimal places after the decimal point. So if you have 3.14159, you'll get 3.14 with 2 digits of precision. And this is this number here. Oh. This is this number here. Okay? Now on to the other, well, yeah, as I said, F2. You can just see, let's see if I can find them. Just check online to see where they were. There might be a link in the presentation somewhere, but I don't remember where it is. You can just say C# format string, and then let's see, they're custom, they're standard, and there is the method itself. I think it was kind of tricky to get to where the actual table was, but there was definitely a table which contains all the information that you need to properly, okay, yeah, format specifier. This is the table that I was talking about. So, well, that was one of the results. You must, you can easily find it. It was just, what was it, C# format string, and it was custom numeric format. So, these are some custom numeric formats. This is the placeholder, this is a digit placeholder. 0 placeholder you've seen so far when we say 0 point, where was it? 0.0000. This is basically the zeros correspond to the digit that you're at. For example, the first digit after the decimal, the second, etc. If the digit is missing, like in the case of 1.234, if digit is missing, as you saw here, in 1.234, it extends the number to 6 digits precision with zeros. So it adds 3 zeros, that's what we saw at the start. It just gives you 3 more zeros. But instead, if I write the symbol for a number, and I write it 6 times, it will not add zeros, or shouldn't add zeros. And as you see, where there is a digit, it provides you with the corresponding number, but if there is a 0, it just cuts off. So it will not show you the trailing zeros. So that's the difference between the two. As you see, the symbol with corresponding digit, if one is present, otherwise no digit appears. If one is present, in the case of 0, 0 appears otherwise. So that's the difference between the two. Make sure to note it in case you're using those. The decimal point is the decimal separator, obviously. It's what we use in basically the Western world, I guess. In some different cultures, I think in German, it's still a comma. But in the English-speaking world, it's a dot. Bulgarian, I've already forgotten what it was, but yeah, you just set it in your regional settings, where you can say, let's see where it was. You can go to your somewhere regional settings, if I can find it. Oh yeah, regional language settings. And then you go to location, keyboard, administrative formats, probably additional settings, I guess. Yeah. And then you can put whatever you like for a decimal symbol. If you put something like a number or something, it will still show up, but it's probably not completely descriptive. But yeah, as you see, the comma in the English-speaking world is mostly associated with thousands. So you have like 123,456,789.00. So the point is a decimal separator, and the comma is a thousand separator. You probably need to check what your configuration is, because this will definitely affect the result in your code. And if someone has a different setting for this, they might not run the same code as you, or they run the same code but they'll get a different answer. So just make sure that you either all set your settings to have a point, or if you want to override this, there is a command that you will see later on, I think, which basically overrides it, says what the regional setting should be for this code, for specifically this code. It doesn't change the whole system's regional settings, but for the execution of this code specifically. Yeah, comma is for thousands. Percentile is just a percentage sign. So if you have 100, if you have 1, that will be converted to 100%. So you have a conversion, multiply by 100, add percent sign at the end. You have like 0.5, you get 50%. You have 0.6, you have 60%. You have like 3, you have 300%. So you just multiply by 100. This is per mile, so this is like 1,000. It's the same as percent, but it's instead of percentile, it's per mile. So it's multiplied by 1,000. So you have like 0.05, it'll be 50%. You have like 0.5, you get 500%, etc. The backward slash is an escape character. Escape characters are commonly used when you have, for example, new line, symbol new line. It's an N. If you write simply N in your console write line, it will just be the N symbol. But if I write a backslash here before the N, it will understand the whole character backslash N as a new line. So be careful with that. If you use a slash anywhere in your code, it's an escape character. So everything after that, strictly after it, will be escaped. If you'd like to, let's see, this next sentence will be on a new line. Let's see what happened. And as you see, next center and you have ns on the next, or you don't have even the n, the letter n, because it's interpreted as a new line symbol. So yeah, if I have backward slashes, they just escape the next character. That's something that's interesting, I guess. If you want to have a backward slash, then you have to use double backward slash. Double backward slash is basically escaping the backward slash, so it won't be interpreted as a symbol for a new line. It will be escaping the backward slash. So you have center, backward slash, and that's what we'll see now. In this case, sentence. This is something that will be used when you do regular expressions. This is something that's a very interesting topic in programming. When you use regular expressions, you'll be using a lot of escape characters, a lot of keywords that find some strings in for example, in a file or in a very long text, and you'll be using those a lot. I'm not sure if that's something that you should be considering right now. But yeah, there's another escape symbol, and that's the @ symbol. If you write the @ symbol in front of the string, it won't have, for example, /n, it won't be a new line because it's escaping every character inside. So we'll just be writing it strictly as it says. It says /n, it's /n. It makes the whole string basically literal. Makes it, everything you say inside is literal. I think there was something about double quotes or single quotes. Like for example, if you want to escape double quotes here, let's see what this will give us. Yeah, double quotes escape single quotes. Yeah, because for example, we would like to do that. I don't know when or why, but if you'd like to do that, then this is the behavior. If you want to escape double quotes, just put double quotes before them. There was some other strange thing. I don't know. It might be in the other slides, but yeah. Let's see what else. Okay, let's continue with the demo. It's getting a bit longer than expected. Yeah, the F2. I was just telling you that you could check all these formatting variants here. There was some other table. That's not the table that I was expecting actually. There was a table that will give you like the numeric. Oh, this is yeah. Okay. So you have a number with an n. You have the percent with a p. You have the round trip or something like that. Oh yeah. So the hexadecimal, what was on the slide here, on the previous this slide here, the x is actually a hexadecimal. So if you write an x, whatever you write as an integer or any other argument, it will try to convert it to a hexadecimal presentation. Hexadecimal is just a number in base 16, and I'm not sure if you'll be handling those anytime soon, but just as information. And yeah, fixed point, I guess. It's not floating point as I expected, but yeah, the F here stands for a fixed point, and you can give the precision. For example, the F1, it just okay. The standard date and time is completely different. But yeah, you have F1, which will give you 1 precision, 1 decimal point precision. F4 will give you 4. And in this case, it's zeros. So it will add zeros at the end. If you use fixed point F or F2 or F3, etc., it will use zeros. It won't use the number sign. As you saw previously, the number sign will end where you don't have any more numbers. So the number sign has different behavior. You must have some other, there was some other like natural number, etc. But yeah, you have loads of examples here. If there is any problem, just check those out. There are a lot of those. Well, let's just end the demo and have a quick break. Okay, well, this is kind of important. The alignments, I haven't talked about those yet. The alignments were those comma and an integer optional arguments that we saw on the slides. You can use those to obviously print a menu with Coca-Cola, Fanta Dizzy, Gorka, and some prices, I guess. I don't see any prices. I guess oh yeah, okay, you have the prices. It's 120. It's a bit optimistic, but yeah, let's see how that's formatted. I guess we've seen that a couple of times already. It's formatted in the following way. You have Coca-Cola, Fanta Dizzy, and Gorka in the first case. Let's see. In the first case, they're all aligned here without an alignment. There just is a space between them. We'll see this in the code. They're not aligned. In this case, they're aligned to this separator line. This is a vertical line. In the console, when you write the symbol vertical line, it will not be a continuous vertical line. Instead, it will consist of two separate small vertical lines. I'm not sure why the console does not handle the vertical sign that well, but that's the behavior. And as you see, those are the prices, which are also aligned. We'll see now what the code is behind this. Like I was just giving you, and this is the ending. It's just a bunch of vertical lines. Let's see how this is achieved. In the first case, as I told you, there is no alignment. There is just a space between them. And since all the digits from 0 to 9, they have the exact same size. They all have the exact same space and the dot as well. So you expect with the space, those all to be at the same position. So it's a third position. All the characters basically are the same size, so they're aligned. For example, in using different fonts or using different font sizes, I guess, you can have characters which are not exactly spatially equivalent. In this case, they are. So yeah, you don't have any alignment here in terms of optional argument. Here you have it. So this is the argument, as I said, comma, and then a number. If you write -15, in this case, everything will be aligned to the left, and then there will be an ending to the right. The whole string will be 15 characters. Let's see this. The whole string, this should be 15 characters. Coca-Cola plus these characters up to here. What was the rectangle? Wasn't a shift? Caps lock? Well, I forgot what it was, but yeah. The whole thing here should be 15 characters. And let's see if that's correct. I have 1, 2, 3, 4, and then 4, 8. And I have 1 in the middle, it's 9. So we should have 6 characters here. Not sure if that's correct, but yeah, we have 2 here. And yeah, I guess we can have 1, 2, 3, 4 more. So I guess these are all 15 aligned to the left. Let's see the code again. What does that mean? 15 aligned to the left means they're all starting in the same position to the left. And then no matter how many places the string has, it must have less than 15 obviously, but it doesn't matter if it has 12 or 10, etc. It will end at that and add spaces or blank until the end, until it gets to 15 characters. As you see, these are all blank here until the vertical line. These are all blank, etc. So this is the first alignment, which is the left alignment. And then you have a right alignment, which is 10 to the right, and fixed point 2 means, as we saw, 2 decimal points after the decimal, 2 characters, 2 digits after the decimal point, and a 0 where there is no character available, no digit available. And this 10 is the right alignment. Let's see this. Our line to the right has the following behavior. It will write the actual string, which in this case is a number, and has 4 characters or 4 places. 1 is 1 character, the dot is 1, 2, 0, and then the remaining 6 will be filled here. So I have 1, 2, 3, 4, 5, 6 characters to the left. These will all add up. These all should add up to 10. So if this, for example, because they're all equally big, they're all 4 characters, you can't really see the difference. But let's see, for example, one of them was 1 point. Well, they're all F2, so let's format the last one, or the second last one, to like 4 digits. And then, which was that? That's the first one, which is Zagorka prize. We go to Zagorka prize, we do like some bunch of numbers. Let's see now, this time we have more characters from the string. We have 1, 2, 3, 4, 5, 6 characters, so only 4 will be added towards the end. Interesting behavior that I'm not really sure about, and I'll just test it now, is what happens if it's longer than 10. Let's see, it's longer than 10, what will happen? Let's just add more, like a bunch of numbers, and say F, let's say 15. Let's say 15. Let's see what happens. Well, it just shifts. So because the previous one was aligned to here, it will just continue on to the next available space to the right. I'm not sure that's expected behavior, but that's what you get. And let's see the other way. If it's left aligned and it's more, what was the longest one? Fun Dizzy, orange. Let's see. How many are these symbols? These are 25 symbols, it says. Okay. 3, 6, 10, 16, and 2 should be 18. No, doesn't matter. It's more than 10, it's more than 15. So let's see. It's aligned to 15. It has more. What happens? Okay, it just pushes to the right. Well, I guess it always pushes to the right in this case. But yeah, just test this on different alignments, see how you can play with those, see if you get what you expect. The last example here is the hex value. As I told you, X is a symbol for the hexadecimal representation. 32,378 must be 2 to the 15. So if you divide it by bytes of 4, by bits of 4, you should get a 1. You should get, you should get the symbol F, I guess. F is 15. Something like that. Let's see. 7E7A. Why is this true? 7E7A. A is 10. Well, I guess you should check it out in base 16. But if you want to use a hexadecimal representation of some number, you just use the X formatter, and then you get it. Okay, well, we'll have a quick break now, and be back by, let's see, what was the time? Be back by 3 o'clock.
Ale je pense tellement que c'est pas risqué de la Урока свършили? Свършили урока? Моля? Значи, ще лекторстваме още малко. Не чакаме да излезе.
Хотел с по-бързо да ми остави, ако мога да се
Си съдят неща. Ема, то няма проблем, защото ако ми кажете да бъдете нещо не е разберено.
Да не треведаш.
Ония ден оставали 2 часа и нещо са ме обяснявали за двойната система на чисто бинарна. Така ви двете лекции, за които се изследват прегласни следвали, останаха 40 минути, значи лекции колко време е било нужно, за да се изложи, да го разберем, а не само да се учите, че сте прочели.
Alright, let's continue with the lecture. Let's see how far we're going. Okay, 3 minutes. I hope I can get through the later parts a bit faster. But yeah, I hope everything is clear by now. Do you have any questions on the first section about different outputs, different alignment, different formatting, strings, etc.? If you have any questions, just feel free to ask them. Let's move on. Reading from the console. We have 2 different ways of reading, depending on what we want to read. We can read input, which is in case of, for example, strings or any data type. We'll use the console read methods or console read line. But if we would like to read a key from the keyboard, as I said earlier, if we want to read, for example, the key escape or control or any other sequence of key presses, then we use the read key command. They're both on the console class but they differ in behavior strongly. We can read different, as I said, types of data. We can read numerals, we can read strings, we can read characters, we can read double, we can read float, we can read, well, also numeral type, yeah. We can read a lot of different input. And depending on whether we use console read or console read line, we'll get different and sometimes unexpected behavior. Console read is something very interesting. It does not read the character given and give you a character as you would expect. It reads the character by converting it to an integer. So it sees what the ASCII value of the character is and gives you that value back. So basically it's something that might not be completely intuitive, definitely not to me. It's not something that you would expect. It's called read. So it should read. And the read should not return an int, but that's the behavior. So be careful when you use it. You will not get a character. We'll see this in the demo. But as I said, you need to convert it back to a character if you would like to use it as such. You will always get an integer value. As you see here in the example, if you use console read and you get some character, then you need to assign it to an integer value. So this is int I, and it's console read. So console read returns an integer. You cannot have a character here. You cannot say char I is equal to console.read, simply because the console read command does not give you a character, it gives an integer. So if you'd like to get the character, you have to convert it here explicitly by converting the integer to a character. This conversion is mostly correct when you use the set of positive numbers, and it will sometimes fail when you use a very big number. But since we expect the integer return to be one of the characters that we know, or maybe don't know, for example, the Chinese hieroglyphs or something, but you will always have to make sure that you can convert it to a character, because sometimes you might get an input you simply can't. But if you'd like to get the character, you first get it as an integer, then convert it explicitly. The next line says the code of, and then the character. The character will be shown as the character itself, for example, A, B, C, D, and its code, which is 1, will be the integer value, which is taken from the ASCII table. Let's see what the ASCII table actually is. Something that is important to not really know by heart, but at least know what it is, how to get to it, and what those different numbers and characters mean. So in this case, just note the decimal and the character representation. The hexamal and the oct do not bother with them for the moment. But yeah, the character, for example, A, which is 65, the character A, capital A, is represented as an integer with the decimal value 65. So if you'd like to have the character A read from the console with console read, you will get the integer 65. If you get the B, capital B character, you get 66, etc. And then you will get, for example, for the lower characters from the alphabet, you get, for example, for lower F, you get 102, etc. So the ASCII table is your reference if you want to find out what integer maps to what character in the computer representation of our symbols. Because as I said, the strings or words or characters are simply for our own convenience. The computer does not know what it is, what those stand for. It only understands binary, bytecode, etc., and it does not understand those literals. So in order to convert them, you can use this ASCII table as a reference. And the more interesting values that you might want to note are the carriage return, which is 13, This is slash, this is slash R. This is 13. So this is a special symbol. This is character return. And then you have the slash n, which is the 10. So this is LF, or new line feed. This is this one here. 10 for new line and 13 for character return. Because you will see those sometimes in consecutive order in Windows to represent a new line. Those will be, if I remember correctly, 1310 character return first, then n. But yeah, check the slides here, because I forgot. The ASCII table, something very important. Let's see if there is a demo here as well. Yep, let's go to the demo. Let's make it a bit bigger, make the code bigger, and run it. Oh, okay. So this is a very common problem. You have to change the project that is being run. You go to the solution properties, and you just have to select the current selection. Current selection means that whichever source code is open currently, it will be run, and not a different one. Because if you had, as previously, the configuration always start when you print it to console, it will always start this project. You might use that for your homeworks or an exam. It's something very important to know as well. You just use current selection, apply, and then you get the expected behavior. So you're at the reading characters demo. And currently it does not give me a full screen for some reason. Let's see, reading characters. Oh, I guess this is the full screen. Okay. So we started, and then we read a key. Let's see now. We input a key. Okay, we haven't got to the keys yet. So, what should I input? If I input B, enter, it will give me the code of B, which is 98. And this is the ASCII table. This is the ASCII table, as I told you. You check 98, and it is indeed B. So this is the code that you will see here. The code that you will get, or the integer that you will get, will always be the ASCII value for this particular character. And then the next line is 13 of something. Let's see, what is it? Okay. So as I told you before, the return keys, character return and new line, they have their own lines. They have their own values in the ASCII table. So for example, the slash n is 10, the slash r is 13. And in this case, what did I do? I input B. Let's do it again. I input B. It might not be visible. But yeah, I input B. And then I hit enter. And what does enter do? It gives you a new line. A new line is character return slash r, new line slash n. So the next line, as you see, is now the character return, which cannot be even shown on the console, is 13, or the code of the character return is 13. It's a bit messed up here, but that's basically the case. If I input two different letters, for example, B and H, then if I press enter, you'll get both of them to show with the code applicable to that. B is the second. After 8, so 8 is 97, you might want to note 97 as the beginning of all lower numbers, or 65 is capital A, beginning of all capital numbers, capital letters. I just forgot the 0, 1, and 2, they were also notable or noteworthy, but yeah, just use the reference table for the ASCII codes. Is this clear so far? This might be a bit trickier and a bit harder to get, but if you have any questions, just feel free to ask. might just show you some more. Let's see. Let's do the opposite though. Let's print the character. We can do the opposite. We can print a character. What do you think the bell does? Might be some kind of sound. So how should we do that? So right line and then character. Let's see. Let's do int I is equal to 7, I think it was. Let's see. The 7 one is the value. 7. Oh, but we already have I. So let's just comment this. I forgot the shortcut. Control K, Control C. Yeah. All right. This is this shortcut to block comment the code is Control C, comma, or you just do it afterwards. Control K, or no, the other way around. Control K, Control C. I forgot what I pressed already. But yeah, you can check that in the menu in the options. You can change that as well. So yeah, block comment. Block uncomment was something like Control K, Control U. Yeah. So Control K, Control C is comment. Control K, Control U is uncomment. So we have the integer I, and now we want to write it, but not as a number, but instead as a character. And we use Control I, Control right line instead of Control right, because there's really literally no difference apart from the new line. But let's see, we'll convert it to a character. We'll do character of I. Let's see what we get. You probably can't hear it, but there's a big. Let's see if I can. That might be noticeable now. Increase the volume. Let's see. Yeah, that's it. You might do it a couple of times to be able to do it. You do this by when you're at the end of the line. You do Control C, copy, and then when you do Control V, it just automatically prints a bunch of those characters. A bunch of those, same. The whole line is copied on the next line. So yeah. Now I get like a bunch of bells. So yeah, you can play with that. It's really funny. You can do a whole song with that if you know like at one point what sound to use. You can use. I think there was a built-in console beep function, which is the same basically. But in this case, I think there was an input, which depending on the input, it's a different note. For example, this A, B, C. Those are the notes in English. But yeah, console beep should do the same thing. Yeah. So if the console beep or console right line of character 7. Those two should be equivalent sounds because console beep does the same thing behind the scenes. A difference is that you can do different. You can use different notes, as I said, like A, B, C, D, and you can put it in a different order, and then you can put like different times between those notes, so you can build a whole melody if you like. I forgot what there was a term for the sound between for the time between two notes, like some tact or something. I forgot. But yeah, you can do that. Let's get back to the presentation though. Any questions about the read? Basically, don't use it. I mean, you have the read line. Like, why would you want to get a number which doesn't give you any information? You have to convert it back to character. That's not something that you want to do. Just use a read line. Read line will give you a lot better behavior. The read just sometimes gets messy. You need to convert it back. You need to make sure that you remember that it's not a character. So yeah, let's see the read key command. What does it do? It waits for a combination of keys. For example, as I said, you can press Control, you can press Alt, press Escape, you can press any key on the keyboard, and it will just store it in a variable. So as you see here, the variable is of type console key info. You don't have it's not an integer, it's not a character, it's not one of the types that you've seen so far. It's a console key info type. So when you say console key info key is the name of the variable, so you can name it whatever you like. But when you say console key info, it means the variable stored in this type will be a key. It will be a key from the keyboard. And then you assign it to the console read key command, which will give you the input key, the one that you just pressed. Console write line has some. Okay, yeah. Console write line will give you just a visual separation of the key that you just pressed, I guess, and the next line. But yeah, let's see this in the demo. I need to get back to the solution. Reading keys. Again, full screen, grid size, font size. Okay, well, you have the same code here. And let's see, you can't really see what I'm doing, but I'll just press Control, or let's see, I'll hold Control, press K. And as you see, this gives you full information about the key, about the modification that you've done. Well, holding Control is what I did, even though you couldn't see me. This is the modification. The key number is 75 apparently. If you lay down all the keys on the keyboard and it starts iterating over all of them, K will be the 75th one, or maybe it will be the 76th in a zero-based numbering. But yeah, in this case, it's number 75, so it's number 75. Character entered is the symbol for male sex, obviously. I don't know why I just assigned that to Control K. I guess it has some internal conversion. What else can we do? Let's see if I hold Alt Escape. Just not what I expected. But yeah, let's see. Okay, there's some other things that you must know. If I hold Control Z. Wow, it's interesting. Okay, Control Z usually kills the process. So it shouldn't have given me the output, but basically because it's listening for an input, it does not register those keys as those key presses as controls. Like doesn't really note the function that they do. Instead, it just simply reads them as keys. So you probably won't have the, let's see, Control C here. Let's see. Okay, Control C is the only one that doesn't. Well, sometimes it reads it as a key, sometimes not. Control C just stops the execution. So it does not read it as a key. It's overridden. So the override is you just stop the program. It doesn't read it as a key. But yeah, I can play with it. Let's see. K. It's just a K. If I hold Control Alt K, we have the special keys now as an array of Alt and Control. What else can we do? Let's say we just press Enter. Press Enter, yeah. Well, this is a way to get input. When have I used this? We were making a simple console game, and when the user pressed, for example, left or right, let's see the arrow keys. For example, if I press left, and it just gives me the left arrow. So if I want to get input from the user who's playing my game, if I try and get the key info by reading the key, I can check what did he press. Did he press left and move his character left? Press right, move his character right. Or if he pressed something else, for example, say A, which means shoot, or some other function in the game, some other action that you can do. Other than that, I guess listening for key inputs. It's something that a hacker would use for getting someone's password, for example. By listening for key inputs, you can check what they pressed in what order, and you just input the same thing and just crack their password, I guess. But yeah, there are some use cases for this. I doubt you use it for the exam though, just something interesting and something you should know. Any questions about the read key? Just read.
How to hack the parliament?
I can't really give you that information, but you can check it. The question was how to hack the parliament.
Google it.
Yeah, you can try Google. It's not even in the advanced topics. I don't know. Maybe someone will hold a seminar later. I don't know. All right. Well, console read line is the most commonly used command key to read or method to read input. You'll be using it in your exams, definitely. You will be using it constantly, I guess, when you want to have input of any sort, basically. Because console read line just takes the whole input as it is, and then you can use some conversions, which we'll see later on, that will give you a number, that will give you an object of your desire, and it will generally be the most commonly used thing. If the end of the input is reached, it returns null, which you might never really encounter. When would you encounter a null? Null terminating could be some file, I guess. If you're reading from a file, there might be null. But in general, when you read from anything, it will end with a new line. So when it gets to the end, it will not return null. It will just return the string until the new line. So it will mostly work as expected. The null part, I'm not quite sure. I think it was when there was an end of file character in the file, and then it just gets interpreted as a null. Don't quite remember. Let's see how you read strings. Was this straightforward demo as well? As I said, it will be the thing that you most commonly use for your homeworks, even for exams, for anything. This is okay. Yeah, let's see this. As we saw earlier today, when you do console write, it will not give you a new line. Whatever you write will remain on the same line. The cursor will remain on the same line as what you've just written. So as you can see here, the cursor is on the same line. I'll just close this program and show you if I had written here console write line, then the cursor would be on the second line. Oh, just disappeared now. But yeah, there is a cursor there, really. Yeah. So yeah, there is no write line, there is no new line at the end. So we continue here. So what do we do? It says, please enter your first name. Covering the time. Zoomed in. But yeah, let's say Stanislav. And then please enter your last name. Velkov. And it says hello, Stanislav Velkov. This is the read line, this is the most commonly used. But as you see here, it expects a string. What happens if I write 57 and I press enter? It stores this as string 57. It does not store it as the number 57. Can't really break it here because it just takes the string. There's nothing interesting here. Control K, let's see. Well, it's still a symbol for masculinity, but yeah, you see, you can put anything here. Since it's a string, you take it as it is. You take it as a string, and it's literally whatever you type there. It's nothing interesting about that, but let's see the conversions. Those should be the interesting ones. Okay. So you don't always want to read strings, and you actually most of the time will be reading numbers, since most of the problems are probably of some numerical nature. You have to add some stuff, multiply, etc. You will be reading numbers. But if there are strings, you cannot really do any integer operations over them, numeral operations over them. So you would like to parse them. What does parse mean? Parse means interpret these as something else. If you want to parse them as integers, it means interpret the string as an integer. And this operation can also fail, because the string Stanislav cannot be interpreted as a number. it does not go over every character and just give you the ASCII codes. That's not the correct procedure. It just tries to get a number from the characters themselves as numbers. That was not completely clear, but what I mean is, if you have 1, 2, 3, 4, 5, 6, 7, this is a number. If you have the word bold, that is not a number. So obviously when you parse, you try to get a number from something. And it can fail, since that thing can be something different than a number, obviously. Let's see this. This is the int parse thing. The int parse method is the method which parses the string that you input as an integer. So if you input something that is not an integer, it will fail. You can also parse long. Long will try to convert the string that you input as a long, as a numeral type long. Float also can be parsed, and the format exception is thrown when the string input cannot be converted. So for example, we have the string 1, 2, 3, and it can obviously be parsed to an integer. This is definitely correct, because it is integer itself. If you want to parse it as a long variable, you can also do it, because integer is contained in a long variable. So basically, it's an easy conversion. The other way around could fail. If you have an integer which is if you have a long which is bigger than an integer, you cannot convert it to an int. You must have seen that in the primitive types and operators, etc. in previous lectures. But yeah, let's see. We have the invalid string. This string is not a number. It has XXX, which are just a bunch of characters. Those are not numbers. Those are not digits. So obviously, if we try to parse the XXX1845 string as an integer, it will fail. It is not an integer, simply as. So it will give you a format exception in this case. This is a simple program that just converts whatever you input to an integer. So this is called chaining of methods. Chaining of methods means that you do not have a separate line here above saying, for example, string input is equal to console.readLine, and then on the next line int a is equal to int.parse of input. You do not have this. Instead, those two lines are combined in one line, which is this one. You have the console read line method inside as a parameter, and this will give you a string, obviously, because console read line always returns a string. Now, whatever you return in this string, you can now parse it. You parse whatever is inside to an integer, and then you return it to a. So this is chaining. You parse another method. So you get the console read line, which reads a string, and then you parse it to an integer. You can do that in two lines, as I showed you. You can first get the string from the input, and then parse it as an integer. But in this case, it's easier. Sometimes it might get harder to read, depending on how many different methods you chain. But in this case, it's pretty straightforward. You can use that in the exam, you can use that anyway. You don't really get even code review in your exam, so no one really would care if you'd use that or if you type it into separate lines. It's something that might come up in the high quality code course or something, but it's not really that important. And as you see here, we saw the placeholders. We have the multiplication, the addition. I showed you where it can fail, where I didn't. Let's see. If you have too many or too few, let's use this one. We have 0 and 1, right? Then we can have first name, last name, and then again first name. I can have like a new variable here. Let's see. Int age is 15, and then you get like first name, and then and then age as well. So we have too many arguments and too few placeholders. That's completely fine. It would just take the first two, those two, first name and last name. It will not bother with the rest. But if we do, okay, okay, yeah, exactly. First name, surname, so last name, and then you can see it does not blow up. It just shows us what we expected, the first name and the last name. It does not bother with the third argument, which is first name. It does not bother with the fourth argument, which is age. But if I had 0, 1, 2, 3, 4, and 5 here, these are all 6 placeholders for 6 different arguments. Then, if I had only 3 arguments, then this will blow up. Let's see if it compiles first. Does it compile? It compiles. So the compiler is not smart enough to blow up here. Though if you start this, and then you print, again, some name and some last name, this should blow up, because it does not have the necessary arguments to replace the placeholders with. So the exception, it says index must be greater than or equal to 0 and less than the size of the argument list. So basically, the index, which in this case is 3, since we have the 0, let's see, the 0th one represents first name. The first or one represents last name. 2 represents age. But then 3, this is the index which is out of range. This cannot be found in the argument list. In the argument list, you only have 0, 1, and 2. And 3 is, as you see, well, it's a format exception, so it should have been an index, but yeah, it's format exception. So yeah, let's say it's just that the index is out of range, and it's not. It cannot be found in the argument list. It's not one of the arguments. There are too few arguments. Okay, I showed you that. Any questions about this? So far? So good. The conversions, they will have a demo shortly, but let's finish the slides here. Wasn't that a similar slide there? Okay, so instead of parsing, you can use an equivalent method which instead converts something to something else. So in this case, it converts a string to whatever you like. You can convert it to an integer, you can convert it to a single, which single you might not have really seen so far. It's the built-in type for float, because in Visual Basic we have single and double. We have those as baseline for all other languages. So when C# is compiled and converted to intermediate language, in that intermediate language, floats are singles, because in Visual Basic they're singles, and all the other languages throughout the .NET framework, they're all converted to one representation, so that it's interchangeable. You can use that intermediate code in another program where you input different language. For example, C# code that is compiled to intermediate language, it could be used in the Visual Basic program where the language is also compiled through the CR. So in this case, single is float, int 64 is long, and double is double. What else? You can see those when you just type convert. Let's go back to this code even. Let's just type convert dot, and then you can see all the different types that you can convert to. For example, we have convert from base 64 as a character array, string, etc. And let's see where those twos are. Yeah, so you have to base 64. You have to bullet, to byte, to character. I don't know if it can be seen, but I can't really scroll zoom in at the same time. So I'll just read them to you, but you can check them easily. You can convert to decimal, you can convert to double, to etc. Whenever you choose one, should say to double, then when you open the brackets, you can see the different overloads. Overloads means you can input different parameters in those methods, and depending on what you input, it will convert it in a different way. For example, if I input a boolean here, it says bool value, it will convert it differently than if I input something else. You can scroll through those with the up and down arrows, and you can see the different overloads. You can have byte, you can have character, you can have datetime, decimal, double, float, integer, etc. There are 18 different values that you can convert to double. So depending on what you input, it will be converted. For example, if I convert false to double, it should convert it to a 0, because the 0 is the representation of equivalent to double. Let's try this. Convert to double from false. I should have probably printed it. Let's see. Wow, this will be tricky. CW is a snippet. I hope you know it. CW, tap tap. It gives you all right line. This is something I will be using all the time. And then I'll just copy this. I'll just copy this here with double semicolons. And then yeah, the double representation of false is 0. False is nothing, or the lack of something, or something which is 0, interpreted in a number format. Whereas a true might be converted to a 1, I guess. Yes, and the double representation of true is 1. This will hold the same for integer. But you can, for example, convert to double a integer value, which would be, for example, 345. It should still be 345, since I haven't specified a precision. But now, if we use what we've learned so far, we have the 0, or our only argument here, which this will be the argument, this whole thing. This will be converted to a double, so this whole variable, in this case it's not really a variable, but this whole argument is a double. So now, we can use the formatting strings. We can say, let's convert it to a fixed point with precision 3. So this should be 345.000. This is what we get, 345.000. If we would like to, we could use the number formatting. Let's see. And then we do this. It should not have any zeros, since the number does not change the lack of number with a 0. But yeah, it just says 345. Okay. Yeah, you can use those, convert to single, to double, etc. Let's see the demo. Maybe make another pause after the demo. Yeah. Okay, so we're reading numbers. Reading numbers. You've already seen this. I'm not sure. That's nothing new, really. But anyway, you'll see how you can get input from the you can input whatever you like and then parse it and see how it blows up. Actually, what it says here is A is equal to. Since, as we spoke earlier, this is console right. It's not console right line. The cursor is on the same line. So when I type, it's here. Now, it expects me to give an integer, but I don't know that. So I just input whatever. It has to blow up. Why? Because it tries to convert it to an integer. That does not work, because ASCII-FAKUS-HF is not a number. So obviously, it will say input string was not in the correct format. So it will give you a bit better failure. This is because of this line here. Int A is int.parse. As I told you earlier, parse is taking the input, which is a string, and tries to convert it to an integer. It does that behind the scenes, but basically, well, there are different algorithms. I've written an algorithm, but I'm not sure if that's the way that they do it. Anyway, so I can input like 37, this will be correct integer, and then I input another one, say 3, and then I'll get the sum and product of those two. The sum is 40 obviously, product is 111. Now, for f, again, I'm not sure what they expect of me, so I can write anything. It should blow up, yes, because we're dealing with numbers now, and I don't know that. So it should be probably written somewhere, like, let's say, a is equal to, and then when we get a failure, well, this is pretty advanced. I'm not sure if I should share it. It's basically how you can catch the exception, and then, well, let's do it anyway. We can do try this. Well, I forgot the syntax. Let's see, try. And then when this fails, you can have catch format exception. I think that was I can't remember now the syntax. Let's see, try catch syntax. I haven't been using that in a while. Try catch C#, and you get the syntax here. It's try and then catch. Oh, okay, so it must be in brackets, so that's the problem here. Catch and format exception. You can give it a name here. Format exception. And you can basically, when you take it, you can just write it just to see what it is. Format exception dot message, I think it was. Yep. So what does it do? It tries to do this line here. If a format exception is caught, then it writes the format exception message. So this does not compile because the name A does not exist. So we'll have int A is equal to int A, just simply. And then we'll have A is equal to int.parse. This should compile now, but it's used afterwards. So we should assign a value to it, let's say 0. Well, so it's not very straightforward. Anyway, what I do now is I input something that is not a number, it blows up, and gives me only the exception message. It gives me input string was not in the correct format. This is the inside string of the exception. You can see that if I comment this and bring back the int.parse of line, and now I do this, same thing, I just input some rubbish here, and then I get the exception. You see the message is inside. Input string was not in the correct format. This is what I'm looking for, this is the message. But all the other things, the stack, etc., it's not really what I'm looking at. Well, I'm looking at if I want to fix the exception, but in this case, if I only want the message, I can get it this way. And now, what do we do with this? Why did I start doing this? If I find out that this is not the correct format, I can give a proper message to the user and say, for example, A should be an integer. Or let's start this with invalid input. A, which can be in single quotation marks, should be an integer. And then when I input something here, it will say live input, A should be an integer. This is a better way to tell the user what you expect him to input. Also, this should stop the execution of the program possibly, or return the user to input A again. What is done, what is shown now is not correct because the execution continues, and now I can input B, and then A0, etc. But this is not what I want. I want the user to input A. So I can do this in a while cycle, for example. And I can say, have you done cycles already? 4 cycles, while cycles. Okay, this might not be really that easy to understand. But let's say while, true, or this case. Let's do this. It's interesting. It's probably not. You might not understand fully what's happening, but it's interesting to see. Let's say boolean is valid is equal to false, and let's say while is not valid, or while not is valid. Do this. So if it does not blow up, is valid should become true. Let's see if this works. So what I've done here is, okay, I should use this is a endless cycle since I do not get a new prompt to read line again. So I want this also to be, so I want the whole thing to be inside the, I need a new prompt. So basically I want to have the user input again the same thing. So I have this, copy, and then let's see, try this. So we don't need this anymore. Okay, so I'm trying. Go right line. Then I'm reading what I've input and I'm parsing it. And until it's valid. Okay, so let's see if this works then. Filters. Line is not. Okay, line is used afterwards. So let's say string line is equal to the empty string somewhere. String line is, I don't know if you've seen this, you can use string.empty, and this is equal to an empty string. But it's easier to see what it is. It's better than just simply writing a double quotation marks. Okay, now let's see if it's okay. It should be okay. Let's see now. I get the input, A, something, invalid input. A should be an integer. I input something else, invalid input. And until I input a number, this will ask me for a number. If I input 4, it continues on to the execution of the next line. So you can check this in the video, I guess. And yeah, this is a bit of an advanced topic. But this is the cycle, while. And it should also be in a block, but I haven't done it in a block because I've not been using a language that has a block in a while. But yeah, let's say it's in a block, and then you do this. Try and get the input. If the input is parsable, if the input is an integer, then continue, because is valid becomes true, not is valid will become false. So it will go outside of the cycle. But since is valid is false to start with, this is true, so it's executed, this block of code. You'll definitely see more in depth about both cycles and I guess try-catch might be too further down the road. But anyway, it's, yeah, just if you're interested, so for the more advanced people, I guess. Let's see, towards the end of this, we have f, which is a float. So again, if I return the code to its original state, where we had the parsing and, okay. So for, again, we have a float, so again, it expects a float. let's say I have 12, 13, and then for f, again, I can't input a string because it will blow up. I'm not sure if I show that again. And then if I input for f, for example, 3.45, it will be shown as 3.45. It will be parsed to a float. If I want to parse a integer as a float, it won't have any problems as well. Like for example, if I have 34 here, it will be parsed as a float because 34 is 34.0 and is the same number basically, float or int. You won't have a problem. There will be a problem if I want to parse an integer and I input a float, for example 12.3. This will blow up since the string is not in the correct format. This is not an integer, this is a float. This cannot be parsed. So, yeah. Any questions so far? This might be a bit, I guess the parsing should be okay, hopefully. You will use it in the exam. Basically, when you get the input from the tests, you can read the line, convert it to a number. It's int parse from console read line. This is all that you need for the exam, I guess. You might have some more complicated parsing strategies, but I'm not sure they will be on this exam. Like, some part of parsing will be when you parse, for example, a 3D matrix, when you do arrays. But that's probably in the future and not a topic for current discussions. We'll have another break now until, what was it, 4 o'clock? Yeah, 4.
Трябва тия текста на компютър, колкото ще си пишеш домашно. Я да ти се прецекни тук. Защото най-компютър нещо не запазва. Не можеш да направиш. Ти се пак почне.
Как мога да го служа левите? Тук да си върнат още 2-3 от това, да не вземем една седмица отпуска, за да ги разлачат.
Как е? Успя ли да ги откажеш? Това е обед на дряма, така нали знаеш. Какво знаеш? Пак ще. Къде беше обим? И как там? Супер интересно. Буквално пауза. Това да му ги конвертирате. Между другото трябва да ми платиш видеята и Монако ще да си наврат.
Добре, Dropbox си дам да си.
А да, това е най-добрият вариант. Аз ще да предложа точно това. Не дадеш. Да, бе, колко ти да си смисъл. Нали имаш Dropbox с това? Ако нямаш, не можеш да направим Dropbox, който да си за време за лекции и там ще ги крием направо.
Аз не ми избира съм.
За презент. О, значи... За петка ли? Я ще го се преди на край. Аз съм честно днес. И утре ще бъда. Така. Викаш интересно там. Има моментализация. Аз не съм се играл много с странно. Трябва да иначе на какво пишеш? Може и така да е, просто ще знам, че работи идеално. Той пазя на колко знае някакво температура, не се казва, че му ти го прави, да се казва.
Не мисля, че се опаска това. Пак се смисъл само пращаш с него, какво пращаш. Разликата е, че го представи, нямаш представи, че той си първа типа без да му кажеш, като трябва да кажеш равно 15, а нямаш лоб, нямаш да, нямаш и пар, нямаш нищо. Кажеш равно на 15, те вътрешно разбира, че това е число и че това е число, което споделя от инки, но прави и той си интерпретира от една точка, това че целта интерпретира, т.е. не се копирам и чете го си. И като го прочете ти парсва за това, което е причина. So най-готовите list comprehension и diction comprehension. Аспекти масивите могат да си направиш, ще ги генерираш с думи много готово. Примерно, взимаш ми това от тези коси и се генерира колекционер.
Това трябва да се качи и да се свърда с това.
Ти вече не си такъв?
Да, съм преместен
с трил.
Малко е лака на базата и се прави на работи, които трябва да завършат намазан там, дето се намазан тези дваната пичове.
После ще се лечим на лекта.
Да, минимално. Да му мога да държи прави период, някаква плаща се да не Еми супер, направо може да всички на момчето и като много малко видеа да си някакво своето съотен. Да, като свърши лекцията мини пресовка. Ай, това е.
Докато си изучиш, пък да вземеш да тръгнеш да взимаш на плод, дали няма да си
Good job. We'll have to go back to English now. Someone should have mentioned that. I didn't give it a chance. Alright, so what did we see so far? We saw the triparts in my code, which is equivalent to the inbuilt or the built-in triparts method, which we'll see now. So if you had any questions about the previous block, even though you won't be using the same block, you're using the same logic behind it. So we saw if we want to convert or parse a string to an int or to any other numerical value, we basically might run into a problem when there is no explicit conversion possible, when the string is not a number. Then I showed you can do that in a loop, which you haven't seen yet, but you will see. And do it until the user gives you a number. You just do it infinitely many times until he actually gives you what you want to. This same thing can be done using the method try-parse. Try-parse tries to parse, which obviously comes from its name, the string that you input and output it into a variable that you've already declared. So you need to have a variable that will store the parse. You need to declare it first. You should say int number, for example. Then you do int.tryparse of the string that you just took from the console. And you have this keyword out, which you probably haven't seen yet. out is a very complex topic actually, because the topic basically covers reference types, value types, which is kind of advanced. So I will not explain what exactly it means. For now, just keep in mind as syntactic sure syntax, you have to write out number. What it does, I'm not going to explain why or what it does behind the scenes. What it does is it parses the string as an integer, or it tries, obviously, and inputs it in number if it succeeds. You cannot omit out. You need to put out. It's just syntax out, and then the variable that you have. For example, if you had here int age, for example, then you had to have int dot try parse of string, or the string that you put, and out age. So you need to have the age. So what does try parse actually do? It returns the parse value number if it succeeds, but if it fails, it gives you a boolean which gives you false. So basically, let's just remove this message from the top of the screen if possible. So basically, you can input it in a logical construction. You can say if this succeeds, or if this is true. This can be either true or false. If this is true, then do this line of code. Write line valid number. If not, or else, write that this is an invalid number. So, try parse does two things. It returns a boolean, so the evaluation of this is a boolean. But in the background, if it succeeds, it inputs the parsed value into number. So it does two things, as I said. Parses the number and gives you a false or true if it succeeds or not. And let's see the demo. It must be, it will be more, it will be clearer now. See the demo. This is it, simple. You have the declaration. You cannot omit this. You need to declare a number. If you do not declare it, it will not know what number is. So if I say int age, this should not compile, because invalid arguments, it says cannot convert. It does not know what number is. It does not give you a very good error, because it says cannot convert from out number to out int. That does not mean anything actually. But it obviously cannot find number. So you have to declare it, and after you've declared it, you only need to do the try parse part, and if it's a valid number, if the string is convertible, then it will give you a valid number and the number itself, or it will give you a invalid number and the string. If I give you here, let's see this in it does not give you a prompt, which is not good. Let's make a good prompt here. Let's say console write. There is no snippet. There is no snippet for console write. What we can do is use the console write line snippet, which is CW, tap, and then just delete the line part. So yeah, console write, and say, for example, your number is, and then this will be a prompt for input. So now I have your number is, now I can input my number, say, for example, John, and it will say invalid number, John. Now if I input 56, it will give us valid number 56. So obviously it fails if it's a string, which is not convertible, and it gives us the proper string, the proper number if it's convertible. Let's see here. If I do invalid number, what do you expect to show up on the console? Any guesses? There was a guess?
False.
False. It will not show you false because the number itself is of type integer. So it will show you something that's integer. The execution of this whole thing is a boolean. This, if you hover over it, try parse, it will say bool. So this means that it itself is a boolean. It gives you true or false. But the number, when it fails to be, when the parse fails, it will simply give you your original declaration. Your original declaration was 0. Why? Because when you say int number, it sets 32 bits in the memory, which will be used for the integer type. But those 32 bits are not set, they're all zeros. Since they're all zeros, this is the default value for int, which is 0. So whenever you declare, for example, double some number, this will also give you the default value for double, which is 0.0, which is the same as 0, but the double code. So, right, since it does not get parsed, it does not get input here, it remains 0, the original declaration. If it's succeeded, as we saw in the first case, it will give you the right number. For example, 134, it's 134, so it's a valid number. So what I showed you last with the cycle and giving you a permanent or perpetual prompt, like give me the number, give me the number, give me the number, until the number is given, you can do that again with cycle. And this is again a bit of a vast topic, but yeah, you can do while here. And then this will be where you want to put the result if it's a valid number. So while this thing, okay, so if this is true, then this will be executed. Well, I want to have this to be false. Since when it is false, it's invalid. So when it is invalid, I will say invalid number. Your number is, and I'll do the same thing. But if it's correct, it will go outside the while cycle, and it will say valid number and number. Let's see, this should work. Oh, I don't have a console read line again. It would have been a perpetual cycle again. Your number is. Okay, let's see now. Let's see now. Your number is John. Invalid number, but this time, since I changed the string to the number, it gives me the number, which is 0. If you recall, invalid number, here it should say string. Why? Because we need to show the user what his input was and why it's not valid. So what we do now, when I say your number is, and I say John, it will say invalid number, John. And we'll ask again, your number is. I say Peshul. Say the valid number Peshul. If I say 45, it will say valid number 45. So this is, yeah, when you go over cycles, you might want to go back to this lecture, see what I've done in those two cases. It's not a current topic, as I said. When you see cycles, it will become more clear. For now, all you need to know from this demo is try parse, gives you a boolean, true or false. If it gives you a true, then this number has changed to the parsed one. If it gives you a false, if this whole thing gives you a false, then number is the number that you have declared first. Because if I have the written number is 5, it will be the number 5 always, until I change it. I say John again, Let's see, what did I do? Invalid number. Alright, well, I guess it just resets it to 0 then. Since we declared it to be 5, we cannot parse it, and then it's 0. Invalid number. Yeah, I guess it resets to 0 then. So that's something new for me as well. Yeah, okay. Well, every time try parse is executed, it nullifies number, I guess, which is not something that you would expect. I don't think it's a correct behavior, because I don't think you want to change number if it fails. If I were to use this, I would expect number not to change unless it can be parsed. But do note, it does change to 0, so make sure you don't lose any information if you were expecting something different. Any questions? Yep, there's a question. There's a question if we remove the not at the front. So what do you expect to happen? If we have this now, the while cycle itself will only be executed when this here is true. Until this becomes false, this whole block will be executed. So maybe you want to wait until the topic of cycles and see what we mean by that. But basically by changing the not parse to the parse itself, this will give you a try parse every time it is correct. This is not what we want. So if we say 13, it will give us, and when we give something rubbish like John, it will go through, which is not what we want. We want the opposite. We want, when it fails, do it again until it does not fail. Okay, any more questions regarding this? Let's go back to the lecture then. As I said at the beginning about the original settings, this is something that you can change inside the code. So when we try to print some special characters, we run into trouble because the console does not understand Cyrillic, for example. If I try to write here, let's see, we don't really need any of that. Let's see, if I write line Gosho, it will give me these strange symbols, which in this case are question marks. When in some cases it might be some random symbols that we don't understand. And this is because the encoding is not set. It does not understand Cyrillic. So in order to make it understand Cyrillic, we need to change the encoding. How would you understand encoding better? Encoding is a set of rules how to map integers to characters. So we have the ASCII table. This is a mapping which only goes up to 127. This has only 128 characters. In this ASCII table, there is no Cyrillic alphabet. There is no A, B, B. It means that you cannot print those characters using those 128 symbols. In order to extend the ASCII table, you need to change the encoding. This encoding only understands the first 128 characters. But if you change it like this, you say console dot output encoding is equal to, and then you get the encoding dot UTF-8. You first probably need to import the encoding. And if you don't know where encoding is, the the Visual Studio IDE will be very helpful in this case. It will find where this class is or where this namespace is, and it will give you the necessary using. We don't have the using system text in our code, so when I run it, this will not run. It does not exist in the current context. But if I import the system.text library, since encoding is in this library, we can now run this code. It finds the actual class in namespace, and now I can run it. So, in this case, as you can see, we see some other form of strange symbols. So, what we can do is, let's see what the properties here are. Let's see if we can change the font and see if that makes any difference. Let's say consoles, for example. Okay, and run it again. It now shows correctly Gosh. So you basically have to change your console output as well, not only through the code, but through the font that you use, because some fonts might not have the expected characters. As you saw, by default my font was raster fonts. I changed to Gonzalez, and it now shows the Cyrillic. Lucida might also show it. Let's see. Lucida also shows it. But if I go back, oh wait, just have to change it here. But if I go back to raster fonts, it shows us these strange symbols. So raster does not understand Cyrillic. Let me just change the. Well, let's see what should we use. Lucida or Gonzalez? Let's use Gonzalez in this. And you have to change the let's say 7 by 12. That's quite ugly, but wow. Okay, so what encoding was? What font was it? Oh, wait, raster font. Yeah, since I pressed the font. Let's use Gonzalez or Lucida. Can't really tell which one is better. Let's use the bigger one. Let's try now. Okay, it works. Yeah. So there are two steps. Change the encoding in your code. So you use console.output encoding is encoding.utf8, so that you can use the UTF-8 encoding. If you don't know what that is, you Google UTF-8 encoding. This will give you the table of, similar to ASCII table, equivalents of integers to characters. It's the extended ASCII table, which not only gives you the usual characters, as you see 65 is A again, 97 is lower A, etc. It now has the Cyrillic. It won't be listed here, I guess, but you need to check which encodings have the Cyrillic in them, so that you be sure that they will be output correctly. You can be certain that UTF-8 has it. UTF-16 also must have it, but it's not. UTF-16 I guess is not supported in the encoding. You can check encoding dot. You can check. Have ASCII. Do we have the symbols? No. If the encoding is Windows, there's 1, 2, 5. I don't find it, but yeah, I don't see it here. So let's say Unicode. Let's see if Unicode finds them. Yes, Unicode. Unicode finds it and represents it correctly. Let's continue to do the demo, perhaps. Might be here. Yeah. The decimal separator. That was what I said at the beginning as well. You can change that in your original settings. You go to additional settings, if I remember correctly, and then you can change it to whatever you like. You can change it, as I said, to a number sign or anything. It need not be dot or a comma, but that's the most commonly used. These are the most commonly used separators. This is a very important line of code, which you should probably note and use whenever you can. This sets the culture to invariant. What it means is that it will always have a dot as a decimal separator. Regardless of what your configuration, regardless of who's reading your code and their configuration, it will always be a dot. This is the invariant. Invariant means it does not vary. It's the same, it's constant, so it's the way to change the default separator without changing the system configuration. Only the code it will be run. Let's see. Okay, we have the demo now. Let's find the demo. Then we have Arabic as well. Nice. We'll see how that fares. Okay. So we changed the encoding to UTF-8. And interestingly, even my console didn't support. Let's see, let's bring it to defaults. That doesn't even work, does it? Let's try and use the defaults. Default scheme was raster, and it was what, like 7 by 12 or something. Okay. Let's run it again. As we saw with the default console, it didn't work. So if I hadn't changed my own font, it will not show Cyrillic. What I did was properties font, and I changed it to Consolas or Lucida Console. It doesn't really matter. Let's say Lucida Console. Okay. Now I run it again. So the Cyrillic must be displayed. Wow. Okay. It does not save my my changes. I don't understand why it doesn't want to change to Lucida.
Change that to defaults.
Sorry?
Change that to defaults.
On the other one, again.
Okay, defaults, Lucida, 12, okay? Let's see now. Okay, now we have it, right? Thanks. So we have the Lucida font, which shows the Cyrillic, but still does not show the Arabic. So it says that this will not be displayed because the console font does not support Arabic. In this case, it does not. Regardless if I change it to Consolas, it will not show Arabic characters. It's just there are no fonts on this console that will actually show Arabic symbols. So those will not be shown. So let's get back to the default scheme where we could have at least Cyrillic, so that we show something afterwards. But yeah, we saw 3.454. If we run it now, it will show us 3.54. Since my settings, my original settings, say that the decimal separator is a dot. Now let's change it. We go to region and language. We go to additional settings. And here we can change it. Let's say we do the number hashtag. See what happens. Apply. Now we run it and see what happens with 3.54 becomes 3 hashtag 543 number 54, which is because of my original settings. If I had not changed those, it would still be correct. But let's go back. Okay, let's leave it like that. You saw the difference in the next line, right? Why there was difference to the next line? Because there was this line of code which you should note. It's in the notes, but you should also probably, well, not memorize it, but definitely remember there was something about threads, about current thread, about culture. That's not something you should know, like every single part of it, but that's the whole line gives you the behavior that you want. So in order to have thread, you need to have system threading. So if I remove threading and I try to compile, it will not find thread. So when I use the IntelliSense here, there's a little help here. I could using system threading, I could add it to the required libraries. So now I can compile. In order to have culture info, I need to have globalization. If I don't have globalization, I won't have culture info, and it will blow up again. So in order to have culture info, I need to add system globalization. Now, what this line does is, it sets the current thread, which is not something you should be familiar with, but what it is the place where your code is being run. So basically, this is the environment in which the code is being run, and you change its culture to an invariant one. As I said, this is culture which does not change, it's invariant, it does not care what the original settings is. And in this invariant culture, the value will be always 3.54 regardless of settings. As you saw, I changed my decimal separator to a hashtag, and yet it is a point in the next line because of the invariant culture. Invariant culture just makes sure you have the correct decimal value. I'd like to return though to my original settings so that I don't forget. You can either change it, as I said, through here, or using that line wherever you're not sure who will run your code. If you want the person who checks your homework to have the same answer as you and not have some collision when you use dots and commas for decimal separators, just write that line of code. Thread current culture is equal to current info.invariant culture. This will make sure everyone who runs your code will have the same setup and will have the same point as the decimal separator. And the last one was a parse of decimal from a console read line. So I want to enter anything that is a decimal to make sure that it parses correctly. For example, 3.1415. It parses correctly. But if I write some random string, it will give us the exception that we saw so many times today, a format exception. It's not in the correct format. Interestingly, it says I could input 1, 2, 3, 4, 5. Let's see what happens back there. 1, 2, 3, 4, 5. Parse it as one whole number. 1, 2, 3, 4, 5. This is because the comma is a separator for thousands, and it does not get interpreted as a decimal separator. So you can have as many commas, they will be ignored. It won't check if they're every 3 numbers. We know thousands are every 3 numbers, but it will not make a check for that. It will just give you the number joined up through all the commas are being dropped, basically. I don't know if that's the correct behavior that you like, but that's the behavior you get. Any questions so far about the culture or original settings? As I say, you can just note these on the lecture slides or in the demo. It's just this whole line here is the magic, and it should be all that you need to set the culture. Okay, let's see. There are various examples here. We're printing a letter. What does the printing a letter example contain? Let's see, full screen, then enlarge the font size. Okay. You enter some name, you enter a company name, and you get the whole string here. We're pleased to tell you that name or the company has accepted you to take part in the C#. Okay, so I guess it's expected to say enter person name, my own, and enter company name, Softony. And it will say, dear Stanislav, we're pleased to tell you that Softony has accepted you to take part, etc. So what it's used for is for templates. You can make an email template using this code. and basically just input the names and have the same information sent to everyone. So this is mostly, I think, it's built in some of the mail clients. Zimbra, Outlook, I think they have that feature somewhere. I've seen it in Word template, so Outlook should support the same thing. But yeah, if you'd like to have a template and you don't know who will be filling it out or what names you input, you just use this as a placeholder. And in Word there are other types of placeholders, I guess. There's usually like name or something like that, or name, where the name gets input. But here in C#, that's just the curly braces for placeholder. And you can just type it all out and have different inputs for different receivers, so for different people you're going to be sending it to. And use the same code all over again, so it's automation, it's informal automation. Let's see, calculating area. This is another example that you can do. I don't think it's strictly related to strings, but you can. Yes, of course, you can have this program calculate the surface for you. You just need to input the correct sides. So as you see, I need to enter A and B. So that's what the prompt is, I guess. Well, there is no prompt. Okay, here's the prompt. So it says, this program calculates the area of a rectangle or a triangle. So this is very good to have on top of your program, to have a string that says some form of documentation or metadata. It basically says, this program will do this, or this program will do that. Then you have the prompt. Prompt is enter A and B for rectangle, or A and H for triangle. And now I do as I'm expected. I'm inputting A and B, or A and H. They will both be parsed on a new line, as I can see from the code. But if I didn't know that, I will just put a space in between and it will fail. And that's because it's not completely accurate, the description of what they expect me to input. So sometimes you need to develop code as if monkeys will run it, monkeys will use it. You don't know what the user will do. You can expect anything from the user. That's why you should always make it foolproof. You should try and make it so that they can't do wrong, basically. Because now, as I said, I can input 3 space 5 and it will crash. Because it says enter A and B, and it does not tell me that I should input a new line in between. I don't know that, so I can input 3, 4. It will crash, even though I have no idea why, because it does not tell me what I actually should do. So a correct prompt, in my opinion, would be to have this as a console write line, enter A and B, or A and H, and I have a console write which explicitly tells me I need to enter A. And now I know that the first one is for A. Now if I have a second one for B, this will be a place of problem, since if I want to input a triangle, I need to input H. If I want to input a rectangle, I need to input A, B. So what I can do is, I can ask the user at the start, do you want to do it for a triangle or a rectangle? Now, this is basically specializing your program. At the start, we were trying to do everything. We're trying to calculate the area of a rectangle and a triangle, regardless of what you input. But we can now branch. We can say, would you like to calculate the area of a triangle or a rectangle? So, let's say, would you like to calculate the area of a rectangle? And then we can say R, or a triangle, T. Now the user has to input R or T. So we need to check the input. He or she might not give us R or T. So we need to make sure we, again, account for all possibilities. So what we can do is check for key, for example. So let's check for that. What was it? Console key info key is equal to console dot read key. So now we expect the key R or the key T to be pressed. And now we have the key. So how do we check which key has been pressed? We must have a bool rectangle, for example, or is rectangle. Is rectangle is, let's say, true. And now key dot key. This will give you the key. So you get the key pressed. And now we have to check it if it's console key dot R. This will be a Boolean expression, so we do. So we check it. If key dot key is equal to console key dot R, then is rectangle is true. Now how should we proceed here? The logic here could be either to check is rectangle or is, let's say is rectangle is false, and then is triangle is also false, so that we don't have bad logic here. So we need to have both of them. So if the keys are, then rectangle is true, and else if key dot key is equal to console key dot T, then is triangle is true. So now we have to check for B here, since A is always the same. But now for B, we can have a check. If is rectangle and is not triangle, then we'll write B. And of course, in C# you don't have the words that you need to use the double ampersand sign. If is rectangle and is not triangle, we'll output B, and else if is rectangle and is triangle. So basically, it is a triangle. It's not a rectangle. Then we'll input H. Now let's see what we've done. Anything at all. So this program calculates the area of a rectangle. Would you like to calculate the area of a rectangle or a triangle? R gets printed? Why does it get printed though? Let's see. A is 13. Now B correctly is something else, 14, let's say. Oh, nice. It had code in its towards the end, I guess. Enter 1 for rectangle or 2 for triangle. Let's see where that code is. I haven't even read the code so far. Okay, so enter 1 for rectangle or 2 for triangle. All right, I guess. But you don't really have that, like. Okay, obviously. So you don't really need that anymore since we checked that earlier. But yeah, this is only needed in this case for calculation of the area, because the area of a rectangle is simply the product of the two sides that have been given. But the area of a triangle will be half of that. So this is a separate input that had to be given, so that we choose whether to find the single area if the choice was 1 or 2. So if the choice was 1, we'll simply divide by 1, which is the area of a rectangle. And if the choice was 2, we'll just divide by 2, which is the area of a triangle. But in this case, since we already know that we either have a triangle or a rectangle, we have the same logic and be applied to the area. We don't have need for choice, and this will be inside our new block. So we have, if it's a rectangle, then the area will be itself without being halved. It'll just be the product. However, if we have a triangle, we'll just divide by 2. Now, area needs to be declared in advance, and it will be set to 0, as I told you earlier. When you declare a variable without setting it, it just defaults to 0 in the case of numeral values. There are some problems. It says use of unassigned variable area. Well, we'll just there is a way to check if the variable is assigned or not. For this, we need to use the nullable type. Have you seen this? The double with an extra question mark at the end is a nullable type. So when we declare it, it should be null. Now, if the area is not null, it will be printed. But if it is null, we can print something else. Now let's see, can we use a string here? The first one is a double. I doubt we can use a string here, since they must both have the same. Yep. It says it cannot be applied to operands of type double and string. So we need some other value here, which is not really correct, because if I say 0, then there is 0 is still something that can be. It's unsigned. Okay, we'll assign it to no. It is not assigning itself. Yeah. So yeah, you can use another check here basically to not write 0 as an output, and if you want to input your area, your input is invalid or something, you can do that. But yeah, let's see what's happening now. Would you like to calculate the area of a triangle or a rectangle or triangle? I'll press T now, and it's written down, and I need to check why this is. So, but yeah, let's say we have 10, and as you see, H here is now the input. Since I pressed the T button, it gets checked if it's T, it's triangle, hence it gives me the height, not the other side. So if the height is 5, we expect to get 25. The area of your figure is correctly 25. Let's see now, can we change the fact that our T is being written on the console.read key info. Not quite sure why it catches the T and writes it. It does not make sense though. Since we have console write here and we just write A, and before that we have console read key, which should read just one key. Not quite sure. But yeah, as you see, it gets written with the A. Here you see again correct behavior. One side is 10, the other is 4. We are dealing with a rectangle, so the area is 14. Play around with it. I'm not quite sure. Investigate why that happens. Why do you get the pressed key to be written down? You don't really have a read line until here. I'm not quite sure. Well, this will not compile, so we don't have a. Well, yeah, that was. Do you have any questions on this now? Apart from why we didn't know? Yeah?
It's written with capital T, but we'll check for small t or capital T for the.
Yeah. The question was whether the key pressed, whether it will check for a capital or a lower. That was why I used the keys. because the key does not really have a lower or capital itself, the key. It has modifiers which make it lower capital. This does not depend on whether the user inputs capital or lower. What we can do is we can read a single character, and then we check if the character is the lower or capital, which is the equivalent. In this case, I use the console key to give you another demo demonstration of where you can use it, which might not be the best use case, still. And to show you that it does not matter. And as I said, you can possibly press the Shift K, and then now this will give you a wrong answer, as I said, because now we don't have either of those, and it just won't know what you expect to get, like, and you're zero. So this is not correct behavior. What needs to be done is basically check if both are false, as it was at the start. Then something must have gone wrong, and you didn't input the correct key. And of course, at the end, you should check if area is null. Then you should input something like invalid input or some other form of invalidation, and then else. And then in the else clause, you'll give the correct answer if the input is correct, of course. So you won't have area 0 because you know it's not 0 anymore. So now you won't have a case where, for example, you have where was there an issue? Okay, if I input k, right? If I input k, and I set 10 and 5. Then we'll say invalid input since the original input is wrong. So basically, you have to check here if the keys are T, and then if it's not in the else, you can give the user a warning. You didn't input RT. I don't know if I'm calculating a rectangle or triangle. So do it again. So you put the whole thing in a cycle again, and yeah, you check the cycles and see how that works. So that's how you make a game, actually. That's exactly what you do. If you input something you don't really want him to, you give a warning. For example, that's not a valid key, that's not a command, or that's you're not doing, or you don't give him any response because the keys that he's pressing should not actually perform anything in the game. Any more questions apart from the key stroke? Let's see what else. There was summary. Okay. Well, what we did today was check input and output from the console. You saw the right and right line at the start. The difference was the symbol for a new line at the end. I think I showed you, I'm not sure. The character for a new line is 13. Oh, well, one of them was the carriage return. Let's see that. I think it was somewhere in the code. Reading numbers, was it? No, it's reading strings. Nope. It wasn't reading characters, I guess. Yeah, this code that I commented out. Let's see it again. Just a very, very quick summary. Let's see now. I don't input anything, I just input the enter. And it gives us both characters. /n, which is 13. And /r, oh, the other way around, of course. /r, carriage return, which is 13, and /n, which is new line, which is 10. So those are two of the characters that you need to know, 13 and 10. Those are the new lines. So those two combined, as I said, in Linux, it's just /n, in Mac OS, it's just /r. Apart from that, right and right line are completely equivalent. I do believe console right line calls console right and adds a new line. If it does not, you could do that and it will be the same thing. So does not matter which one you use, depending on, of course, what you would like to have at the end. If you want to have a new line or not. Read and read line, that's a very tricky part there. You need not use read at all. Like, very, very few use cases for read. You'll get an integer, which is not a very... maybe if you want to check what the ASCII code for a character is, you can check that with the read. But if you're parsing character by character, it's not a good idea. Since you get a number, you have to convert it to character. You get a number, you convert it to character. It's an unnecessary operation. You can just do a console read line, you get the whole input as characters, as strings. It's fine. Then you have to parse it. We saw the second part was parsing. When you get a string of characters, it can be characters which represent numbers. Those can be digits, for example. Then you can parse it to an integer, you can parse it to a double, you can try and parse different to different numeral types. You saw try parse, which does the same exact thing as when you do it manually. When you try catch, as I showed you, it's again an advanced topic, but it's an equivalent behavior. So the try parse tries to parse your string as an integer or as a double or whatever you like, and it gives you a Boolean result. Either it's true, it succeeded, or it's false, it failed. And the out parameter, that's something you should know as well, it's where you input the result when it's correct, of course. When it's false, you saw it's always 0. It goes back to 0. You saw the regional settings, if I recall correctly. You saw the positional arguments. You saw the formatting strings. Check that out. Check them out on the MSDN to see what the different combinations have. Like the X was hexadecimal and F was fixed point. I don't really know them. I check them if I need them. I believe that's all. Do you have any questions on today's lecture? Anything that's not completely clear? You can watch, I think, the same lecture by Teodor. I think it's in Bulgarian, so if language is any better, then there shouldn't be a problem there. And he might say some more interesting things, as I've said before. Different lecturers have different focus, like put different focus in their lectures. I might have trailed off a bit from the material. Some other lectures might be more focused. So, well, yeah, that's it. Thank you. See you.
Что говоришь?
Ние можеше да си направим също.
Можехме, ама...
Камерата си гледам.
Yeah.